Hello. In this video, I'd like to look at projectile motion and using technology to help us solve the vertical components of this. We can use our knowledge of quadratics from pre-cal and applied in order to solve the vertical components because our vertical motion always forms at least part of a parabola. Let's take a look at what this actually looks like. Now remember, when I'm looking at a projectile motion, my vertical position as a function of time works out to 1/2 times my vertical acceleration times my time squared plus my initial vertical velocity times time plus my initial vertical position. If I look at this, I can right away recognize that this and this and this form a quadratic in our standard format. This is the A term, and I know that my acceleration here is always going to be negative 9.81 meters per second squared on Earth. My initial vertical velocity is going to be whatever the question has. Might need to decompose my velocity to get my vertical component. And notice that this does not have to be positive. This could be negative if I'm shooting at an angle downwards. My vertical position here, my initial vertical position, depends on what sort of problem I've got. So let's say that I'm launching from the ground and landing at the same height. My launch and land are the same. In this case, my dvi would be 0 because I'm launching and landing at the same height. Let's say that I have a problem where I am launching from a cliff and landing at a lower height. In this case, my initial position is going to be greater than 0 or positive. The other option that I could have is I might launch from the bottom of a pit or the side of a building, and I might end up landing on the edge of that building or cliff. In this case, my initial vertical position is going to be less than 0. I'm launching from a lower height than I'm landing at. This is important to remember because when I'm setting this up, if I want to use my quadratic skills for this, I have to be really careful that my signs are correct. My acceleration is negative 9.81. Make sure your VVI is correct sign, and make sure that your DVI is also the correct sign. If you know that, and you know that your signs are correct, you can use technology such as Desmos, or you can even use your quadratic formula to solve for the time it takes, the total time. But that's a little trickier. It's doable, and it can work if you're good with quadratic formula. Let's see what it looks like in Desmos here. So in Desmos, what I could do is I could start off by doing a simple case here. 1/2 times negative 9.81 t squared, and I end up with a quadratic with the apex at 0. This isn't particularly helpful because we're assuming the x-axis is the ground here, and in this case, this doesn't make much sense because we threw underground. But if I start filling this out, so let's say that I just drop a ball off of the edge of a building, well, my initial vertical velocity would be 0. I can ignore that, but I could say maybe it's a 10-meter tall building. And here we go. So my parabola looks like this. Edge of a 10-meter tall building. It takes 1.428 seconds to hit the ground. Easy as that. So technology is really nice when we're solving things like this because it's really straightforward. Let's say that I launch the ball from the ground with an initial vertical velocity of, say, 4 meters per second, and I don't have any distance. I'm just launching and landing at the same height. So my initial distance here is 0. What I've got is the same thing here. You can see here's my time. It took a total of 0.8155 seconds to return to the ground, and halfway is 0.4077 seconds. That's useful. This is a useful way to find my t total here as I return to the ground. Let's take a look and make this a little bit more complicated. So let's say that not only did I launch it with an initial vertical velocity of 4 meters per second, let's say I launched from the side of a 3 meter tall, 3 meter tall building here. You can see I launched from a 3 meter tall building. So at 0 time, I'm at 3 meters. My apex is here, and my total time is way down here at 1.29 seconds. This here, if I can use technology, is a much easier way of finding how long my projectile is in the air. So by finding out my quadratic, plugging it in, I can figure this out really quite easily because it does the math for me. Quadratic formula will do the same. Notice I'm going to get a -0 here. That doesn't make sense. I'm going to get a +1 here. In fact, if I start plugging these in here, and let's say that that's A and that's B, I can start having some fun with this. So let's say A here is my initial velocity. You can see that it goes higher as I increase my velocity. And also see that as I launch from a higher height, this ends up making some interesting things here, that it goes further or takes longer to hit the ground. If, let's say, I launch from a lower height, let's say I launch from a building that is, or from the ground beside a 4 meter building, I don't even make it up to the top here. I would have to increase this quite a bit to get onto the top of that building. So here I could say it passed the top of the building here, and it landed on the top of the building at 1.237 seconds. So this is a neat way that you can use this to figure out different components for your projectile motion question. And this describes, now remember, this is not the path of the ball. This is the vertical position over time as I go through this. So I'm saying this is the vertical position over time. Here I am launching from below the building, and it's going up and lands on top of the building like this. So this is a neat way of tinkering with this and seeing what sort of interesting displays and ways of solving this I can find. This, again, does provide a neat way to check your math. If you set up your quadratic correctly, you can use Desmos to check if you got this correct. This might also be useful if you're trying to model things or trying to set up a project where you have different velocities and different heights and that sort of stuff. Hope this has been a little bit helpful. Technology is a really interesting tool that you can use to solve physics problems, and this is a neat way of doing this, not by paper. Have a great day.